In this video, I'm going to discuss the ways in which the best bagless cyclonic filtration system is now superior to the best of the old-fashioned bagged approach in commercial household vacuum cleaners. I also intend to address several myths associated with cyclonic technology relative to bags. The way a vacuum bag filters dirt out of the air is fairly straightforward relative to cyclonic technology. Air and dust go in, the bag's pores let air through, dust is netted in the fibre network of the bag wall, and air and less dust come out. The only fundamental parameters of this simple technology are the size of the fibres and size of the effective pores or gaps, which is achieved through the type of weave. There are different kinds of bags, and the best bag technology has improved over the years to address early problems like splitting. They also don't clog as fast due to the use of multi-layer designs and random weaving, which effectively increases the porous surface area. There remain several fundamental problems with even the best bag technology, which the best cyclonic technology has solved. Firstly, while less severe in good modern designs, bags still clog up as they fill, and there's no way around this by definition of how they work. A portion of the suction through the space between fibres when the bag is empty is lost by the time it gets full. This reduces the performance between uses. To compensate for this, some cleaners are required to increase motor input power and use more electricity to drive the air through harder as it fills up, and onboard sensors measure this to make adjustments. This is extremely inefficient. This problem also applies to poorer bagless designs which rely heavily on filters. Bedroom tests don't always capture that motor power increase to compensate for reducing suction in cleaners where it occurs. The new EU motor power cap reduces the environmental impact of this form of sloppy cheating and brute forcing of performance. Because the technology fundamentally isn't very good, many are noticing that bag cleaner performance is being adversely affected by these energy caps, being disappointed with new models which are virtually identical but just with lower motor powers. This is in contrast to the best bagless cleaners, which are still showing growth in efficient performance and show no signs of being adversely affected by the motor power caps. The best cyclonic systems offer fundamentally better filtration technology, with even more potential to develop and improve, in contrast to old-fashioned bag technology, which has reached technological saturation and is experiencing development stagnation. A second big disadvantage of bagged filtration technology is that the bags are designed to be disposable and therefore add enormously to landfill when scaled up across a nation. The environmental consequences of this are relatively substantial. Furthermore, in contrast to bagless technology, which simply puts only dust into landfill, there is also an associated carbon footprint with the disposable bags, from production through transport and to disposal. Again, this is substantial across a nation and completely unnecessary. Bag technology is therefore considered to be environmentally harmful and polluting. The third major disadvantage of old-fashioned bag technology is the running cost. Official manufacturer replacement bags, so excluding cheap copycat cash-in universal bags which don't work as well, are relatively expensive. As of making this video, good quality official replacement bags for a leading bagged cleaner brand are costly. A pack of 4 costs over £10. The pack also comes with disposable filters and fresheners, also adding to landfill waste. I'll discuss the need for fresheners later. Some users report their bags fill in 6 to 8 weeks. If we take these rough numbers, this thus means if the machine is to last 5 years, which is the guarantee period of the better bagged cleaners, the lifetime running costs of the machine can be around £80 to £110, and you can double that if it lasts 10 years. A good bag cleaner itself typically costs comparably to the best performing bagless cleaners at around the £400 mark, so adding that additional typical lifetime cost on top, you're paying as much as the most expensive bagless cleaners. Many people scoff at a £500 price tag on top model bagless cleaners, but if they go for a bagged cleaner, they're seemingly unaware that they're really paying at least that large £500 price tag they scoffed at, and possibly considerably more. These hidden costs are akin to an old technology vacuum tax, and not something that marketing will advertise and presumably hope people won't notice. Another problem is that as these vacuums age and stop being produced in favour of newer models if they last that long, it becomes harder to easily source compatible bags for them. People also need to make sure they stay on top of ensuring they have a supply ready, because if they run out, they can't use the vacuum. This is all avoidable with the best bagless filtration technology. The best bagless cleaners have no running costs or maintenance. Because of the relative high running costs of bag cleaners, some people may be encouraged, from a financial point of view, to keep their bags as long as possible before replacing them. This is bad for two reasons. Firstly, as already mentioned, performance drops or power usage increases as bags fill, which is bad for the user. Secondly, if bags are not emptied, bacteria can grow in the aging dust, leading to odours, and more so for biologically rich materials such as pet dander. This problem is easily and inexpensively solved in bagless cleaners. You just empty the bin, and the smells will disappear if additional smelly material isn't collected. Bagged cleaners, by definition of needing to let the air through to work, fester those odours and pump them out. Manufacturers of bag cleaners are aware of this, and fresheners are often needed to mask bad smells when they occur, rather than emptying a partly full bag, which adds to the running costs. Such fresheners often come with bag packs, along with disposable filters. Some people also don't like or are sensitive to the perfumes in fresheners. In summary of the problems with bag cleaners, they still clog to this day, reducing relative cleaning performance or driving up power usage costs. They're very unfriendly to the environment. They constitute a non-trivial lifetime cost to the user and extra management. And they can encourage growth of odours for some users who have sucked up material that causes smells, but don't want to empty the bag part full. All these problems can be avoided without consequence in the best, more modern cyclonic bagless technology. There are a lot of myths surrounding vacuum bags and associated cleaners. One common myth is that they can clean better because they have a shorter, simpler air path, and that cyclones restrict airflow. This is highly misleading and in fact assumes an identical motor is used in each system, which is of course completely false and at worst deceptive. Motors which drive flow in the best bagless cleaners are built to ensure enough airflow is achieved in a particular cyclonic system to ensure optimal cleaning performance, as measured objectively in industry standard testing. The best cyclonic filtration systems that have been developed are capable of extracting particles out of the air as small as 500 nanometers, and don't need the pre-motor filters that are commonly present in most cleaners. This is extremely fine dust and only about 200 nanometers larger than what the HEPA filter extracts. I've covered this amazing technology in a video with the first link in the description. To achieve this level of filtration relative to older cyclonic filtration, there is no reduction in suction by virtue of how the air system works. Again, this is covered in the linked video explaining how cyclones work. Having narrower tips on this technology doesn't restrict airflow because air doesn't actually flow through the tips. Only spinning dust given enough momentum from the airflow passes through. It's complex fluid dynamics, but the air just comes into the cyclone, spins around the edge, thereby increasing pressure there. Relatively particle-free air diffuses from the edge and flows out of the top to achieve mass conservation, while the now heavier spinning dust is forced to the bottom and vibrated out of the hole into the bin. This is in complete contrast to bag technology. It's possible to produce bags which themselves are near HEPA grade, such as the Micron Magic bags, and can filter out most particles greater than 330 nanometers. But, unlike cyclonic filtration, improving filtration performance in this way using bags heavily restricts airflow due to the need for smaller pores. As such, these bags are rarely used, even on what are considered to be the best commercial household bag vacuums. Instead, bags are used with pores large enough to let enough air through, particularly considering the now reduced maximum motor power that prevents wasteful and inefficient brute forcing, and the cleaners now rely again on washable, or more often, wastefully disposable filters. So the bagged filtration approach is now trailing behind in filtration quality, and can't be improved upon because the limits of the technology have likely been reached. Another myth is that bagless motors are under stress because it's believed that cyclones restrict airflow. As just discussed, they don't restrict airflow. Motors in the best bagless cleaners operate at a constant power because their filtration is unaffected by dust loading if used according to the manual. They're sized, custom built, and tuned for a particular cyclonic air system they're designed to drive. That tuned motor is tested for its lifetime, which is typically around 10 years in the best bagless cleaners. Therefore, the motors aren't under relatively higher stress from having to drive cyclone filtration. Ironically, the opposite is likely true. As vacuum bags clog when they get full, air resistance increases and airflow drops, as mentioned earlier. This relatively strains the motor. Sometimes, to avoid suction loss, some manufacturers increase motor power. This increases relative motor stress further and causes a greater rate of aging. Often, airflows are cited for bagged cleaners as evidence they clean better. As touched on in other videos, and as will be discussed in more detail in future videos, many factors determine cleaning performance and not just suction alone. A vacuum that sucks harder doesn't necessarily automatically clean better across different flow types. How that available suction is used in the dirt extraction process is more important. It's been shown that the highest levels of cleaning performance can be achieved across all flow types using lower suction levels, if cleaner head design is good enough to optimize the other relevant factors involved. Citing airflow alone demonstrates a lack of understanding of the principles of vacuuming. The only way to measure cleaning performance is objectively through industry standard testing, and this must be cited in any claim that one vacuum cleans better than another, and also under what conditions. Casual bedroom tests are simply not good enough to achieve this. The best cleaners will perform the best on average across all flow types, and thus cater, as best as possible, to the most people. Cleaners that are niche performers serve niche audiences. There's no publicly available objective evidence I'm aware of that the best bagged vacuums are the best holistic cleaners. However, evidence is available that the best bagless cleaners achieve the greatest holistic performance across all flow types, according to industry standard testing. In a second video with a link in the description, I've also provided a list of criteria to best judge the holistic performance of a vacuum. There's also a myth that because the best bagged vacuums use bags that have self-closing trapdoors when they're wastefully thrown away, they're more hygienic than bagless cleaners which expose the dust during emptying. While such a bagged system is definitely hygienic and minimises contact with dust, not all bagged cleaners avoid that mess. Secondly, it's possible to empty the best bagless cleaners without ever coming into contact with ejected dust, and this is empirically demonstrated in a video with the third link in the description. There's also the risk with bagged systems requiring disposal of bags of accidentally throwing away important clips on some designs. Users also still have to touch and dispose of dusty filters on bagged cleaners. The best bagless cleaners don't have filters to maintain and are thus far more hygienic in that respect, so it's simply false to claim that the bagged cleaners are more hygienic than bagless. So as a short summary and takeaway message, bags will always lose suction as they fill, even the better modern ones. Some of the best commercial bagged cleaners still rely on filters, meaning their filtration is now vastly outperformed by the best cyclonic bagless cleaners. Worse still, the limits of bagged filtration technology have likely been reached with no significant improvements likely. Bags are very environmentally unfriendly and have a relatively much higher carbon footprint. Higher quality official branded bags constitute a substantial hidden running cost over the vacuum's lifetime. This elevates the price of what are considered to be the best bagged vacuums on the market to comparable or greater cost of the best bagless vacuums which have no additional running costs. So bagged vacuums are not any cheaper and may end up more expensive. Cyclonic technology doesn't prevent good suction or, more importantly, the highest cleaning levels across all flow types. The best bagless cleaners are at worst comparably hygienic to the best bagged designs for emptying and come with the advantage of less landfill waste and environmental impact. The lack of a need to maintain filters makes the best bagless technology more hygienic than any technology that requires filter maintenance. So overall, the best bagless technology offers greater hygiene levels. The shift in market share being dominated by bagless cleaners is clear evidence that bagged vacuums are no longer popular with consumers for many of the reasons outlined here. It's quite likely their days are numbered as the world trends toward greater efficiency and lower environmental impact. There's no evidence that the loss of bagged filtration technology in any way disadvantages customers. Filtration in the best bagless technology is superior to the best that today's commercial bag technology can provide, and the best bagless cleaning performance is shown to be at least as good and in some cases better when considered holistically across all flow types. Bag technology has now been relegated to a niche area for a small minority of users, whilst the rest of the world has evolved and moved on to superior technology without any adverse effect. Hopefully this video has provided a modern update on the place of bagged filtration technology in vacuum cleaners and the gradual global transition to mostly bagless filtration. Finally, it's worth noting that not all bagless technology is good, and a great deal of it is very poorly designed and performs worse than old-fashioned bag technology, This has led to much confusion and resistance to the phase-out of vacuum bags by some bag purists. This issue will be covered in a future video.